So in this session, we'll try to understand about DevOps metrics. There are something called DORA metrics. Okay? DORA is nothing but DevOps research and assessment. Okay? Before we go there, let's try to understand what is a metric. Okay, it's a very important item. Even when you join in your organization, if you're a developer, if you work in support, or if you work in services, or if you work in implementation, if you're a product manager, or if you're in DevOps, or if you're site reliability engineer, even if you're in software sales or software finance, you will be continuously driven by metrics. Okay, what is a metric? Metric is, in our understanding, um, a value which is computed based on certain input and it renders an output. This output is judged in a scale. Okay, the scale can be between 0 to 100, 0 to 1, or 0 to infinity. It can be variable scale, okay, which you don't know. Whether is a fixed scale, this is a normalized scale, this is a unknown scale, okay, unbounded scale. Now, whatever input you have, you use that input. You typically take variables and you compute. Okay, this can be computed based on an equation or based on time or relatively based on dependent variables or independent variables. Okay, and eventually the output is generated and it is judged. Okay, so whatever you do as part of identifying your inputs, computing your inputs, okay, where is this? Identifying your inputs, computing your inputs, and generating a value is called, let me choose a better color, is called measure. Okay, so you measure to define a metric. Okay, with measurement, you will define a metric, you will judge whether you are going in a good direction or a bad direction. Okay, this is typical intent behind why people use metrics. Okay, now you can define new metrics for anything just to check whether you are going in a good direction or bad direction. Let's take NIT Trichy student as an example. Okay, so one type of a metrics you have is your CGPA, which is your either in percentage or in a scale of 10, 0 to 10. Okay, if you want to judge yourself every semester, you will have SGPA, semester grade point. This can be in percentage or between 0 to 10. You will be judged in each subject, okay, in either scale of 100 or 50. So imagine you have 5 subjects per semester, your total score will be judged to for 500. Okay, this is where you come, and in the each subject you will have a mid exam which is total to 100. You have a quiz, assume it is total to 10. You have an assignment, it might be total to some 50, and you will eventually contribute this normalized to 100 per subject and it will go here. Okay, so if you look at the level, this is level 1, which is at a very high level. You will tell whether you're doing a good job or a bad job. This is at a semester level. This is another level below, which will tell you whether you are doing a good job or a bad job. So if you do good in SGPA, your overall CGPA will be good. Okay. Now this is another level abstraction more below. Each subject, if you do well, then your SGPA will be good and your CGPA will also be good. Similarly, if you come down to each subject, if you do good job or bad job in respective entities, your contribution from each subject will improve overall subjects, SGPA and CGPA. Okay. If you carefully observe, there are levels of judgment. Okay. You can further break down this into your day-to-day metrics, right? For example, class attendance, ability to listen to class concept and then remembering them. Okay. Imagine you had 10 classes. You can rate yourself. Am I able to remember 2 classes? Then your throughput for your listen to remember metric is 2 by 10. Okay. If you can remember 8 classes, your throughput is 8 by 10. So it means that you're doing a good job in listening and remembering. If it's less than 50%, then you're not doing a bad job. So if you look at another level of abstraction from a level at a CGPA level to day, you are actually trying to nail down to an individual data point. Okay. That individual data point, if you improve in the form of a chain reaction, you're actually improving the entire flow of events, which will contribute towards your final goal, which is your CGPA. Okay. Similarly, like how you have a matrix with an example like this from a very high level to a very low level. Okay. You can also create metrics for engineering operations or developer operations. Okay. So imagine you are sitting here. You will work with product managers. Product managers work with developers. Developers work with QA. QA work with release engineers. Release engineers work with implementation team. Implementation team will work with sales. Okay. These guys will sell the product. These guys will deploy the product. DevOps will assist everybody in all stages. Okay. Now, if the way you do a good job in your day-to-day tasks, your day-to-day task will eventually contribute your CGPA, like how it contributes your CGPA. Similarly, everybody's success will contribute towards the success of DevOps. Okay. It's not that DevOps is doing good and the rest of the company is doing bad. It will never gonna happen. You will. So if you go back to your example, if you are not good at doing day-to-day job, day-to-day activities, okay, imagine you're not doing good in day-to-day activities, but you managed to not do good in quiz assignment, but you did good job in mid, and it gave you some 70% above, and it will contribute to your each subject, it will contribute to your SGPA, and it will contribute to CGPA, and you will either be somewhere between 75 to 80. Okay. This is how the cascading effect will be. Similarly, in case of dev operations, everybody's success is your success. Okay, the dev operations team's success. How? Question is how? There are 4 terms which you need to remember. One is KPI, okay, which is called as key performance indicators. Okay. Then comes SLA, service level agreements. Okay. Then you have PMs, which are productivity metrics. Okay. Then you will have business targets or business reviews, which are weekly business reviews, monthly business reviews, quarterly business reviews, and yearly annual business reviews. Okay, these are something which you need to know. I'll help you how all these things will map with the metrics of DevOps. Okay, productivity metrics are the key metrics for product management and development team. Okay, what are they? You don't need to know now, but typically we'll try to map it to DevOps metrics and DORA metrics. Okay, key performance indicators are like your day-to-day tasks, which are very, very minuscule in nature, small tasks, which are typically taken care by DevOps team, QA, and release engineers. Okay, these are key performance indicators. SLAs, service level agreements, are typically maintained by implementation, customer support, or anybody in services and sales. Okay, service level agreements are agreements which you write or do with the customer so that you are pledging them that you will deliver a service in particular time. Okay, for example, you bought a Ola electric bike, okay, from Ola, and Ola tells you in India there are thousands of service centers. If you go to any service center, we will give you service. That is an SLA. Okay, another example is like you have Zepto, products like Zepto or Swiggy or Blinkit, right? They give you a delivery assurance time of 10 minutes, okay, which is a service level agreement, okay. So people who are customer facing, like implementation team sales, take care of SLAs. People who do the handholding jobs in the back end works on KPIs, and the product and the dev teams will look at the productivity. Okay, if you do good job in productivity, you will get better KPIs. If you have better KPIs, you will have better SLA. If you have better SLA, your weekly business reviews, your monthly business reviews show good growth. Okay, otherwise they'll show bad growth. Okay, so this is how typical organization structure relies on productivity metrics, KPIs, and SLAs. Okay, SLAs, KPIs, productivity metrics vary from company to company, business to business, use case to use case. Okay, for a food delivery company, the SLA which everybody knows is the delivery time. Okay, but for uh, another better example can be, you all know about broking websites, stock market. Yes, no.
Yes, sir.
Uh, so the SLAs for stock market are something which are not presented to end customers. They don't know it. Like how you know a delivery app's SLA, you don't know the stockbroking SLA because it's too complicated. Why? Their productivity metrics, their KPIs and SLAs are linked to each other. Okay, which are tightly coupled. Okay? So that is why, with the sophistication of the product, your performance, productivity metrics, your KPIs and SLAs vary from product to product, from the team to team. Okay. Now, forgetting all these things, we will now look at what are DevOps metrics. We'll start with DORA metrics. Okay. So, as I said, DORA metrics is DevOps research and assessment metrics. There are two broad classifications. One is velocity metrics. Okay. The other is called stability metrics. Okay. Velocity metrics are for the DevOps team members. Okay. Imagine you have a DevOps team. There are three people who work on Docker, two people work on Kubernetes, one person works on cloud, and there is one lead who works on managing VMs, and there is a manager who does approvals and health check. Okay. Velocity metrics are metrics which will tell the manager, the lead, how my DevOps team is doing. Is it doing good job? Is doing bad job? Do we need to improve? Or are we doing very fairly well? We don't need any advice from anyone. That judgment can be typically taken care by velocity metrics. What are they? Okay, they are deployment frequency. Okay, deployment frequency. The second metric is lead time of changes. Okay, we'll go in detail. Okay, so this is what typical goal of velocity metrics. So these two metrics will tell the manager of the DevOps team how my team is doing. Okay, here velocity means how I am actually managing my work. If I have 100 requests, am I doing good? Can my team do more, or can my team do less? Okay, people who work in industry would be typically puzzled when they join, because a manager typically hires bunch of people in a team and dumps a lot of work. You will always feel that, hey, the amount of work we are getting is too much. We might either need to increase the size of our team, or distribute the work, or plan the work in week on week. Okay, those are the thoughts you will get as an end developers. Okay, but when a manager hires a headcount, they'll statistically look at how much hours a person works, how much effort he can burn, how many tasks he can do. Okay, if you recall your estimation problem in your software estimation class in DevOps, which we looked at in terms of software teams, they do the estimation of work and decide what will be my velocity of the team. Is the velocity of my team is ability to burn 50 story points, 100 story points? What will be my head count? So that is what the manager works. Okay, despite creating a right team size, despite maintaining right backlog, the team may not perform good or may perform very good. Okay, they can be bad, they can be good. So at a given point of time, the manager should not sit idle, assuming that I have 10 people, they have capacity to do burn 100 story points and they will burn. He should not sit idle assuming that things will happen. Okay, he has to measure, to check whether my assumption is the team can burn 100 story points versus the actual, did they really burn 100 story points, is something comes out using velocity metrics. Okay, so deployment frequency, lead time to changes are two metrics which are typically followed by the DevOps leaders to understand how the team is behaving. We'll go into them in detail to understand what they are. Okay, but we will first also look at stability metrics. Okay, stability metrics are two. There are two stability metrics. One is change failure rate. Okay, or it can be called as CFR. The other metric is mean time to recovery. Okay. Now, stability metrics will define the outcome of the DevOps team's work. Okay. So the velocity metrics tells you whether they are doing the job or not as per the plan. Stability metrics will tell whether the job done is making sense to people who asked a request or not. Okay. So if I have to draw a very good example, let's take a instructor. Let's take me as an example. Okay. I was asked to take 15 classes. Let's assume. Okay. What is velocity metrics? To check whether Sai Anirudh has taken 50 classes or not. Okay. That is velocity. What is stability? Did Sai Anirudh manage to teach? Did Sai Anirudh manage to teach the concept in 15 classes and the students are able to understand them or not? What is the percentage of their understandability? Is the stability metric. Okay. So one metric will tell whether you're doing the job as per the plan. The other stability metrics tells you job done is whether giving the right yield or not. Okay. So these are two types of DORA metrics. Okay. We'll go into each of them in detail and we'll calculate how this matrix looks like. Okay. Let's look at DORA velocity metrics. So the first one in the DORA velocity metrics we saw is deployment frequency. Okay. Who are the players? What is the input? Okay. Input are product managers, developers, and QA. Okay. Their job is to write stories. Dev jobs is to complete the stories. QA's job is to test the stories and do release. Okay. So when they do release, are they pushing releases weekly, monthly, quarterly? Is the defines the deployment frequency. Okay. So typically the DevOps team will go in an agreement with the release team that the number of people it hires, the hire count is typically based on the deployment frequency. Okay. If you are doing quarterly deployment, they will hire X number of people. If you do monthly deployment, they might do X plus Y people. If they do weekly deployment, they might do X plus Y plus Z people. Okay. So if you are X, which is your headcount is expected for quarterly release, but you are getting work for X plus Y plus Z, that is something bad performance. Okay, that will impact your team. So that is what will be judged by the deployment frequency. So it records number of deployments you have done week on week, month on month, quarter on quarter, and it compares this value with x, y, x plus y with z. Okay. So let's take one example. Imagine there is a team which has 5 people, and the expectation is they have to deploy quarter on quarter, once in a quarter. Okay. So all these 5 people will do all preparations for 3 months, and in the last week of 3 months they will do the deployment. And once the deployment is completed, for the next 3 months they'll start the preparation. I mean, setting up the images, setting up the environment, infrastructure, staging, prod environment, etc. That those are the tasks. Imagine number of deployments here should be one per quarter. This is expected. But if you look at the actuals, if they are doing three, if the deployment count is three, okay, then 1/3 is something which they are 0.33%. So they are 0.33% only productive, and they are actually 0.66% deficit. I mean, that's the overload they have. They are taking 0.66 of the overload. So this is what QOQ deployment frequency computes for QOQ people. If the team is WOW, okay, if the team is working on week, and if there are 20 people, okay, the expected is for a quarter, how many weeks you have? 4 plus 4 plus 4. See, for the 12, okay, they are expected to do 12 deployments in quarter. Imagine they are doing only one, okay, then 12 by 1 is equal to 12%. So they are not being actually utilized a lot, okay, they are underutilized because there are 20 people, they are expected to do 12 deployments, but they are doing only one, which is actuals once in a quarter, which is they are actually being underperformed. They are underutilized, not underperformed, underutilized. Okay. So the deployment frequency measure will tell, are they being utilized correctly? What is their velocity? If we are doing one, should I need to fire 15 people or move them to different team or increase the deployment count is the decision which the product managers, developers, QA team will eventually take. Okay, so this is the deployment frequency metric. Okay, let's go to another metric called lead time to change. Okay, LT. Okay, this actually a metric which will track time from coding to testing to release to deployment. Okay, this actually computes the time. Okay, so coding is done by dev team, testing is done by QA, release is done by release team, deploy is done by DevOps or implementation team. Okay, DevOps will facilitate environments for all these people. Okay, now if the coding took, let's look at one example of quarter on quarter release. Okay, for quarter on quarter release, assume that the coding takes place for 3 weeks. QA takes place for 1 week, sorry, 4 days. Okay, release and deployment takes 2 days, 4, 5, 6. Overall, it takes 4 weeks. Okay, so in quarter you have, let's take month on month. Okay. So 1 month there are 4 weeks. You are expected to deploy once in 1 month. Okay. So imagine the coding to QA takes 3 weeks. QA to coding to QA takes 4 days. Release takes 2 days and deployment takes 1 day. And assume it is taking 4 weeks to deploy once. So the health of the product is good because you are deploying once in month on month in 4 weeks, which is a good time. Okay, but if your coding happens at 9 a.m. to 9:10 a.m., then your QA is done by 11 a.m. And if you're releasing at 12 noon, and if your deployment is happening at 1 p.m., okay, for a month on month release, this is worst. This is pretty bad. Okay, here the measure is in hours, here the measure is in weeks. So the point is, for a month on month release, you expect the lead time to be in weeks. For a week on week release, you expect the lead time should be in days. Okay, there will be no day on day release, but everybody in the world today, they do hourly release for week on week, daily release for month on month because of the pressure from the customer. Okay, but always the DevOps team rejects such developments because if the lead time to change is higher than the actual, okay, if it is higher than the actual, then you're wasting a lot of time. If the lead time to change is lower than the actual, you're actually causing trouble to the product because you are shipping in a hurry. You're not actually delivering a quality product. You're deploying the product under a pressure. So you will compromise all the security concerns, borderline cases of testing, vulnerability cases. So that will eventually degrade the release of a product and will impact DevOps team because DevOps is the center to everybody. They will facilitate all the machines. If the code is unfinished, untested, undeployed properly, it will eventually hit the DevOps team because they have to revise all those images, Docker images, and have to do a lot of effort, right? That will impact the velocity of the team, right? That will actually impact the velocity of the team. So this number, if the number of requests are high because of too many lead time to change requests, your team will not be able to perform better. Okay, if your deployment frequency is not as per the actuals, your backlog becomes higher and your team will not perform better. Okay, so these two velocity metrics, deployment frequency and lead time to change, will help you decide whether my headcount is working as per the actuals. Is my headcount capable to handle the lead time to change, lead time to delivery in a given actual benchmark? Is my team requires expansion or shrink? Okay, those decisions are typically taken using deployment frequency and lead time to change metrics. Okay, these are typically velocity metrics. Okay, now we look at stability metrics. Okay, so in case of stability metrics, you have a metric called change failure rate, which is in short called CFR. Okay, CFR is actually the percentage of the deployment that resulted in failure. Okay. So, for example, if you go back to the previous slide, the team member 5, their expected number of deployments are 1, but they are actually doing 3. So, they are overutilized. Okay. In this overutilized, if you carefully observe, we are not checking whether the deployment is successful or failure. We are only checking the count of deployments. Okay. That is very important in deployment frequency. But if you look at change failure rate, among those 3, okay, this was QOQ, team size, expected number of deployments, actual number of deployments. Okay, so the 5 team member are expected to deploy once in a quarter, but they're doing 3 times because of some pressure or some backlog or some escalation. Now, among these 3, 2 are failed. Okay, so then 2 by 3, okay, is equal to how much? What is 2 by 3?
0.66.
I'm just checking whether you're sleeping, everybody's sleeping or listening. Okay, so the point is 0.66% of your overall actual deployments are actually failing. Okay, so when a DevOps leader or a DevOps architect looks at all these metrics, he will decide whether to entertain additional requests in a next quarter or only do as per our benchmark, our expectation. Okay, so this will help the leader to judge whether to hire more people because my escalations are high and actual deployments high. Instead doing quarter on quarter, I'll now do month on month. Instead 5 people, I'll hire 15. Now I'll do 3. Okay, with 3, I will have now focus on doing better deployment so I can bring down this failure rate. Okay, so this is what the change failure rate will help the DevOps leaders to take a conscious decision whether to increase the size of the team or decrease the deployment size, deployment count, or don't entertain deployment requests which will eventually cause a failure, because all the effort put by these people will go in vain because they are actually leading towards a failure, right? So they will eventually go in vain. So this is one measure for stability. Okay. Then there is another metric, which is a stability metric called mean time to recover, which is MTTR. Okay. Mean time to recover is the time it takes to restore the service after any failure. Okay. So imagine you have a shopping cart. 100 people are accessing the product. You have designed the health of this web page to suffice 100 concurrent requests. Okay. Now imagine 1 lakh people are hitting at the same time, and this is your concurrent rate. And your page will, your server, if you recall from your first class in Bash, your RAM will eventually hold those user threads. If you include more RAM, you can eventually suffice more traffic by adding load balancing. But if you couldn't, if your traffic is too high, you may not suffice those many requests with the current setup of the RAM, and your website goes down. Okay, when it goes down, what mean time to recover tells you is your ability to bring back this system to online from offline. Okay, is the mean time to recover. Typically, for social networking websites and um, shopping cart websites, mean time to recovery will be in less than seconds, maybe in nanoseconds or microseconds. Okay, why? Because they have traffic coming from different parts of the world, so they should have so many images that will eventually bifurcate the load. Okay, so if one node is down, they should divert the traffic to another node or create another node so that this traffic which is hitting the failed node will be diverted to this. Okay, so the mean time to recovery is the ability or a time to bring back the website or the product from offline to online. Okay, so if you remember from your observability class, the DevOps resources maintain the health of the websites to understand what is the response rate, what is the wait time, how much time it is taking to load time, right? They'll also compute measures like how many times people got 500 errors, how many times people got unresponsive 401 errors, and it logs those data through logs. Okay, so a DevOps architect, what that fellow will do is he will read those logs, compute how many times it went to 500 and how many times the next 200 request. I mean here it's HTTP request. Okay, how much time it took to get 200, and he tries to compute this time. Okay, from 500 to 200. So in a given day, there could be so many 500, so many 200. All the timestamps he will calculate and they will come up with a mean time. Okay. So for a given company, there is no fixed benchmark, but the ideal time for bringing up is uh, without any error or without any less than a nanosecond. Okay, that's typical expectation, but it will never happen. So people will end up reaching milliseconds or worst case seconds. Okay, so they compute this mean time to judge how soon the site was brought from offline to online. Okay, what is DevOps duty in looking at this metric? Okay, DevOps will eventually have to maintain this infrastructure. Okay, like in a PaaS setup or a IaaS setup or a SaaS setup, they'll responsible for maintaining the images, the respective containers, so that you will eventually do load balancing and keep the system up. So when some traffic or it's because of memory or it's because of high resource utilization, if a particular node or an image goes down, you have to have a fail out plan to bring that image back. So DevOps team writes bash scripts to detect. They'll also write sensing jobs to detect which machine has is giving more 500 errors. It goes and reads the log and checks how many 500 errors are part of this image or a container's log file. If it is having more than certain amount, certain benchmark, it will shut down that the container, creates two more containers and loads them into the network in the IaaS or a platform as service setup in AWS or in any cloud platform, and it will eventually ensure that the mean time is maintained. Okay, so an engineering owner sits with the DevOps architects and tells him that, hey, I've created a product and my mean time I expect should be in 10 milliseconds. Okay. So the DevOps architect will make sure that he will take care of enough auto scaling scripts, enough log reading, enough container creation, container killing scripts so that he will ensure that this value is not bogged down. Okay. So all these mean time to recover values are typically shown in trust websites. If you remember from last class, we have seen trust.salesforce, Zoho Trust website where they show what is the mean uptime, mean close time, how many times it failed, how many times it closed, is there any open incident available because of this failure. All these things are typically seen in the observability mode of the websites. Okay, so these are typical DORA metrics. There are many other DevOps metrics which are typically similar to conventional engineering metric, which I don't want to go. But in any given company, um, you will have these four metrics: deployment frequency, lead time to change failure rate, and mean time to recover. So that you can eventually verify the values and check whether the system is. Now the question is, how do you measure and where do you measure? Do you have any tools to measure? Is something which you will have to look at. Okay. There are very good tools available in market, which you can also see they are open source, like Linear B. It's a very good tool which you can integrate with Git. You can integrate with your incident management tools, observability tools, where it will automatically read the logs and will compute deployment failure, all the metrics. Okay, deployment failure, mean time to recovery, etc. etc. Okay, there's another tool which I used to use called Jellyfish. Okay, Jellyfish will also give you some dashboards like this pie charts. It will tell you where are you wasting time. Are you wasting time in deployment? Are you wasting time in development? Okay, it will actually tell you where you are, what do you do in general. Okay, one tool which is widely used everywhere today is the Datadog. Okay, okay, I like this tool a lot. Datadog is typical observability tool which will do a lot of log reading. All you have to do is go to data log, add all the log centers, ask what metrics you want to capture, and it will compute and give you those metrics. Okay, because all of these values typically need to be logged, right? For example, for deployment frequency, somewhere you have to log how many deployments have done. Some place in some tool you have to log. In case of lead time to change, you will have to compute this time. You will get this time in Git. You will get this time in test suite. You will get this time in deployment tools. Okay. So if you give logs of Git, logs of test suite, logs of deployment to Datadog, the Datadog will eventually understand them. The Datadog will eventually understand them and compute those metrics. Okay. So I'll just show you Datadog tool. It's like an observability tool which will do DevOps monitoring, observability, stability. DORA with Datadog. This is a DORA dashboard. There are pre-curated dashboards. Yeah, see, deployment frequency. So it will be judged based on PR merges. Okay. So this data point will get from your Git or your GitLab or Bitbucket. Okay. Or Gerrit. You will get that data and try to see how many deployments you have done. Then you have PR lead time to changes. For example, how many implementations are in dev, in QA, under review, under merge. Okay. Your mean time to restore, how many times the site came down and what is the average time, how many days it took to bring it back, and the failure rate, failed by merges. So the DORA metric, this is with Minware. Okay, okay, this is from Minware. This is from this is from Datadog. Okay, see, Datadog will give you measures like this: your frequency, lead time, failure rate, which services are failing, what are they. Imagine you have 10 products for your shopping cart. This is a shopping cart example. They have stock surge, delivery proxies, cart tracking, payments, etc. So it will break down into individual products and check what is the average time, what is the change lead time, what is the failure, etc., etc. Okay. So this is our DevOps resource when he works in an organization will be supplied with these tools to judge how the system is happening, how DevOps team is working. When there were no such tools, people used to write their own batch scripts, used to capture data and create PowerPoint presentations to show it to the leadership to see whether you need more people in the DevOps team or you need less people. Okay. So this is what I wanted to cover in today's class. Do you have any questions?
No, sir.
Okay, that's all I have for today. Thank you and have a great day.
Thank you, sir.